In this movie, we'll look at how to create a simple user interface for the key full rotation function, which we had written in Part 3. This way, a window will appear, letting you apply specific input values before running the function. In a new Python tab, identify this script as keyRotationWithUI.py. Import the Maya.cmds module and declare a new function called createUI. This function will take two arguments, namely the title of the window and a callback function, which we'll explain later. Each window can be uniquely identified to make sure only one instance is open at a time. Create the window ID variable and assign it to the following value. Note that this identifier should not contain any spaces. Use the window command to check whether or not a window with the given ID is already open in Maya. If it is, close it with a call to delete UI. Now, to create the actual window, call cmds.window with the following flags. The first argument will set this new window's ID. The title flag defines the window's title bar text. The sizable flag determines whether or not the window is resizable by the user. We'll disable resizing by setting it to false. The resize to fit children flag ensures the window automatically fits around its contents. You can alternatively set the window size with the width and height flags, but we'll omit these in this tutorial. To determine how the interface elements will be laid out in the window, create a row-column layout. Set the number of columns to 3. Assign the column width flag to a list defining the width of each column. The first column is indexed at 1 and will have a width of 75 pixels. Columns 2 and 3 will have a width of 60 pixels. The column offset flag determines how a column is aligned. Here, we'll ensure that the first column is aligned towards the right and is spaced 3 pixels away from the next column. Now that we've got our layout defined, we can start adding text, input fields, and buttons. Use the cmds.text command with the following label set to time range to add a label. When an interface element is created, it's placed in the next available position in the current layout. This label will appear in the first column and in the first row of our row-column layout. Add an integer input field with the cmds.intField command. This input field will let the user provide the starting frame number of the animation. The field's default value is set to the time slider's minimum time. We'll use the start time field to store the resulting user interface object. This object will be used later to retrieve its actual input value. Create another integer field to denote the end frame of the animation. Its default value will be the current time slider's maximum time. The first row now has all 3 of its columns filled. The next element will be automatically added to the second row of the layout. Create the attribute label. Use the text field command instead of int field to let the user input a string. Set the default text in this field to rotate Y. We don't need any other inputs on this row, so we can add a blank separator with a height of 10 to occupy the last column of the row. Add 3 more blank separators to create an empty row before we add any buttons. Add a 4th blank separator to align the apply and cancel buttons on the second and third columns respectively. Create the apply button with a call to cmds.button. Set the label value to apply and set the command value to p_apply_callback. When the apply button is pressed, the p_apply_callback function will be called. Create the following cancel callback function, which takes an unspecified number of arguments denoted by the star character in front of p_args. Again, we'll use the delete UI command to delete the current window. Create the cancel button and set its command to the cancel callback function. Now call the cmds.showWindow command to display the window in Maya's UI. To test our interface, write the following apply callback function, which prints a simple message. Call the createUI function using the following arguments. When we run the script, our window appears with its given title. The apply callback function is set to be triggered when the apply button is pressed. The next step is to access the window's input fields from within the apply callback function. Import the Python built-in functools module. This module contains the partial function, which we'll use with our callback function. Modify the apply button's command flag as follows. We'll split this command on several lines to make it more readable. The partial function wraps the callback function along with its 3 arguments, but delays its execution until the apply button is pressed. Add 3 additional parameters to the apply callback function to match the sequence of arguments in the partial call. Keep the pargs parameter for any additional arguments passed by the caller. For our purposes, however, pargs can be safely ignored. To access the start time, call the int_field command with the pStartTime field object and with the query and value flags set to true. Do the same for the end time. The target attribute is a text field, so we'll need to use the text field command to unpack its value. Note that to obtain the value of a text field, you must set the text flag to true instead of the value flag. Print these values to make sure everything is in working order. With the window open, press Apply. Notice that the values we specified are correctly printed to the script editor output. We can now pass these values to the key rotation function we had written in Part 3. Access the current user selection with a call to the ls command and filter for transform objects. In a for loop, iterate over each selected object and call the key full rotation function with the window's unpacked values. Save this script to your file system as keyRotation with UI.py. Save the script to your shelf as UIRote. The Apply button now applies a full 360-degree rotation on the selected object's target attribute in the given time range. In the next part, we'll cover how to create new attributes in a Python script and how to write expressions to drive other attributes.